How do you find the domain of a composite function that combines a logarithm and quadratic functions? Let's have, for example, our f of x equal ln x and our g of x equal a squared minus 3. Find the domain of f of g. Solution. First, we have to find the composition, meaning our f of g will give us f of g of x. So anywhere we have x in f, we replace it with g of x. That is, our f is ln x, so we have ln, instead of x now, is going to be g of x. That is what it means. So let's write this out properly. We are going to have ln, since our g is x squared minus 2, we write x squared minus 2. This is the composition. Now we are interested in the domain. How do we find the domain? The first step is the restrictions that apply. When it comes to logarithm, one of those restrictions is that you cannot take the logarithm of a negative value, meaning that our x squared minus 3 cannot be negative. It cannot be negative value, and our x squared minus 3 must be greater than 0. It must be greater than 0. But we need the values of x here. So to solve for x here, we can have that our x squared minus 3 greater than 0. We take x, we solve for x squared greater than 3, because 3 crosses over the inequality sign, it becomes positive. Now to solve for x, we have to take the root of both sides. Now what taking root of both sides means is actually we are going to have root x squared greater than root 3, because what root actually means is s squared to the power of 1 over 2 greater than root 3. This will cancel this if we expand, and we are going to have that our x is greater than root 3, or we can say our x is less than minus root 3. Now we have the values for x. We can go ahead to write the domain. So our domain now will be starting with set notation. S is the set of all real numbers. S is a set of all real numbers, but our x is less than minus root 3, or our x is greater than root 3. If you want to write it in interval notation, remember there are intervals, right? Set of all real numbers starts from negative infinity to positive infinity. So from negative infinity to x less than minus infinity, union positive root 3 to positive infinity, and this will give us in set notation. For the sake of practice, you can pause the video and try your hands on this example, and when you return, you look at the solution and compare with what you have done if you are making progress. Given that f of x is equal ln x and g of x is equal the absolute value of x minus 3, determine the domain of f of g. You can now pause the video. Solution to that activity. So first we are going to solve for f of g, which will give us g of x in f, and our f is ln x, so anywhere we see x, we replace it with g of x. Now we are going to have the absolute value of x minus 3. And this is the composition. In finding the domain, we check for restrictions. And one of them is that you cannot take the logarithm of a negative value, meaning that our x minus 3, the absolute value of x minus 3 cannot be negative. It cannot be negative. And for it not to be negative, our absolute value of x minus 3 must be greater than 0. And if that is the case, x cannot be, what is the value of x then? X cannot be equal 3, meaning that x must always be greater than 3, because if it's less than 3, this will give us a negative value. So it must always be greater than 3. So if we solve for x, x will always be greater than 3. Now we have all the restrictions. Let's write out the domain, starting with set notation. X is a set of all real numbers, and x must be greater than 3. Okay, and now in interval notation, we are going to have that x is a set of all real numbers that's starting from negative infinity to 3. Remember, because 3 is not included, that is why we are using the parenthesis union 3 to positive infinity, and that is that. For the sake of practice, again, solve this, and you can leave your answers in the comment section. Given that f of x is ln x, let's take ln x, and you have your g of x to be a rational function, which is 1 all over x plus 2. Now determine the domain of f of g. You can pause the video now. When you are done, leave your answers in the comment section. Just for a recap, when solving for domain, always start inside the composition. Check each restriction step by step. Combine restrictions or at the end, then write out the domain in any given notation. Thank you.